Okay, so what's the highest energy situation? I got strongly bonded because it takes more energy to break a stronger bond. All right, I 100% agree with the second part of your statement, but I disagree with the first part. So if it takes a lot of energy to break a stronger bond, then it takes less energy to break a weak bond. Cool. So let's put it, just as do a pair. Bonded on top or not bonded on top? Let's do, I got a bonded on top, not bonded on top. All right, so how are we going to figure this one out, right? Let me put bonded in the middle, just say, right, so we don't have to worry about it. If I'm breaking bonds, which way am I going? Up. So if bonded is here, where's not bonded compared to my hand, above or below? Above, because you put energy in to break those bonds. You're busting the bonds. So not bonded has got to be higher than bonded. All right? Yeah. Yes, that's a very good way. Another good way to look at it is, let me put it this way. Ezra, so let me thank you for that. So what she said was, you have a stronger bond means you have more energy to bond. That means you fall further when you form the bond. It's more of an not just a sort of an but an right? It's much more dramatic, right? So in that case, who's on the top? Not bonded is going to be way on the top. All right? And who's on the bottom? Strong bonds. Because like what she was saying, it's the farthest, so the strong bond and weakly bonded. And you can look at it either of two ways. The way she said, not bonded to weakly bonded is kind of like a little bit of an, okay, whatever. And then not bonded to strong bonded is, a big step down, a lot of energy released. Or, if you got strongly bonded, you got to whack the heck out of it to break it apart. It takes more energy to bust it up than something that's weakly bonded. It takes a lot more energy to break a double bond, say, than a single bond. All right? But that's a really important set of things. Questions about that? Yeah.
So does that mean not bonded is easier to form bonds than strongly bonded?
So it's easy. You'll get more energy out. It's favored for not bonded things to bond. Forming bonds is favored. That's another way to look at it. All right. I have one last conclusion to draw from this. Another therefore. If the bonds of the products are stronger than the bonds of the reactants, delta G, and this is the last, for the moment, a last question I'll torment you with, to talk to your neighbor. If the bonds of the products, what you're turning to, are stronger than the bonds of the reactants, what's the sign of delta G? Take a second and talk about that with your neighbor. The last of these delta G puzzles, right? So so the bonds of the products are stronger than the bonds of the reactants. Products are the end, reactants are the start. So you're going to stronger bonds. What's it mean about delta G? So think about it.